Good afternoon. I'd like to introduce you to our next participant. The Unified SPE Connector status is being back from users. Our speakers today are Seereiner, why you are transferring Philip, our point members support the people care system.
Thank you, Liz. The new unified SPE connector status and impact for users. So as you probably might have heard, there has been a new connector interface being defined for Profinet as some people call it the one to rule them all, but at least a connector that is unified and accepted and realized by many different connector manufacturers. And Thomas and I will have the pleasure to guide you a little bit today through the thought process, giving an insight on what these connectors look like, and of course, talking probably again about some of the use cases. So our agenda today is that we talk about the TFR Ethernet standardization as it is today. We're going to take that. Then, of course, the new SPE connector. What is the idea, the thought process behind it? Then the use cases, and of course, we're going to make a little bit information about the TFR Ethernet System Alliance. Talking about the standards first, I would say. You've already seen that, and here on this lovely pavilion, we've already showcased you many new products which refer to one IEEE standard that supports single-pair Ethernet. So first we have the 10BASE-T1L standard, which is from a channel definition here, the 1000 meter channel definition. We're going to have the 10BASE-T1S, which exists today, which is 25 meter, 8 nodes. And what's new is the new 10BASE-T1M standard, supposedly increasing the range to minimum 50 meters. They're talking about 75 meters in the future, but it will allow you to have much more nodes inside this multi-job environment. And of course, it allows you to have split the power transmission. That's exciting because then you'll have the possibility in multi-dropping your sensors and including a power button. So that gives you the possibility to have small sensors intelligently brought into a single-pair Ethernet now. The other one is the very well familiar 100BASE-T1 standard and the 1000BASE-T1 standard that is released, but also very exciting. The new standard that is currently in preparation from the IEEE is the 100BASE-T1L, which allows you to have 100 megabit at a maximum distance of up to 500 meters. I hope to see some of the first realized product in November on the SPS. I know that several companies are working on the final implementation already now. And this is, again, another game changer in the industry because you can realize now 100 megabit using the 2 wires at a maximum distance of 500 meters. And last but not least, and this is not this much important about the industry, but of course, there is new standards coming up for multi-gig with reduced speeds. It's interesting to know, but this is basically focusing on data center probably and also automotive application. So that shows a little bit the versatility of the single-pair Ethernet protocol as it is defined today and will be defined tomorrow. But before you all guys fall asleep or just watch your mobile phones and emails, we'll talk about connectors. I know that this is really exciting for you guys. You like connectors, and nobody could do this better than my colleague Thomas. Right.
So thank you very much. I said wrong. So before I start, I will tell you, no, where is it? I have to go back. Sorry. It was too fast, Simon. So my topic is the normative situation for single-pair Ethernet connectors. That sounds boring, right?
Mhm.
Normative situation for connectors. But in our case, it was more like a thriller, a connector drama. And I will explain why it was so. So why do you need standards? Standards offers you a wide range of opportunities because you have a planning security. Because if you want to build up a device with one interface and you know that's a standard, it doesn't matter what the others do. They use the same standard and it fits. And that's the idea behind the IEC 63171. This standard describes the single-pair Ethernet connector for industrial applications. And now I want to explain you the drama behind that one. And as you can see here, We start with the IC63171. It's a connector for single pair Ethernet application designed for the protection class IP20. That means for an environment where it's quite safe. So no moisture, only a little bit of dust. So for a safe environment, so the focus for the -1 is building or in cabinet or maybe also data center. The next one is the -2. The -2 is designed for protection class IP20. Again, for safe environment, for buildings, for data center or cabinet solution. The -3 is restored, but the next one, the -4. The -4 is designed for IP20 protections. Again, for safe environment, for building centers, for data centers, or even for in-cabinet solution. The next one is the -5. The -5 is designed for IP67, 65 environment. So where it's actually a little bit harsh. You have wet condition, you have oil, you have dirt. So really for the industry. The next one I want to show is the -6. And the -6 is a sammelsurium of several different kinds of connectors. We have on one hand the rectangular. And the rectangular connector of the -6 is designed for the protection class IP20. So again, for safe protection environment. So for building, for in-cabinet solution, for data centers. And the M8, M12, and M8 hybrid are again designed for protection class IP67, 65 for harsh environments. So again, for the industry. And at least the -7. The -7 is a little bit outstanding because that one is a connector designed for, so it's an M12 hybrid. You have one part for single pair Ethernet and additional power pins to get more power to the device. But now you see maybe the drama behind that one. If you want to build up a sensor, maybe you say, I know which protection class I have. I build it up for protection class IP20. But then you have still the choice, 1, 2, 4, or 6. So the idea behind a standard to have a standard which I can follow and it fits, does it fit in that case? We have different standards for the same topic. And that was the drama behind the situation the last 5 years. Behind all these standards, standing different companies. And the different companies like Weidmuller, like Rosenberger, like the colleagues from TE or from Harting, they invested a lot of money. And they pushed all their strengths to push this standard into the market. But in the end, it was a battle between us. We all tried to convince our customers that our connector is the best on the market and that standard will win the race. But it doesn't happen. So many customers say to me always, I don't know which connector I should choose. And at the end, they said, I will wait. I will wait until I see that one of these standards will win the race. But in the last 5 years, nothing happened. Every company invested a lot of money, but nothing happened. And at the end, the P&O is the Pandora to the ODBA in the US. That's an association in Europe, which gives a suggestion which standard we should use for industrial applications. And they announced last year at the SPS that there will be one standard for Europe. But it's not one of the -1 to -6. It will be an extension to the -7. Because the -7, we was sure that that's the only real hybrid connector for M12. So that does mean that we produce a connector with IP20 protection class, with IP67, 65 protection class, only data, and included in the -7. So we are working on a new standard, the IC63171-7 edition 2. And that one will include all technical relevant connectors. So what does that mean? So most of them I already told you, but one of the most important sentences here is that one. All leading connector manufacturers, so the connector manufacturers who had these battles the last 5 years to show that their connector is the best one, working now together. We all support this new standard. We all invest in new tools to make this new standard reality. And the result out of that one is a planning security for all the investors who want to invest in single pair Ethernet. And our message is now you can really get started with single pair Ethernet. The connector drama is over. To understand how it looked like, so we have here's a uniform connector interface for single pair Ethernet. And I mentioned before, that basis is the hybrid connector standard, the -7. And here's a picture of the -7, one of these types. You have the single pair Ethernet pair, and you have additional power pins. And the single pair Ethernet part is always the same. And as a Profinet user organization, we decided to use this part as a uniform connector and implemented an IP20 connector, an M8 connector, and an M12 connector. So that's the story behind the standard. But now a little bit to the timeline. I mentioned before the official press release from the Profinet organization was at the SPS last year. In April, there was the introduction of the new standard in Milan. End of May was the decision at the IEC to start the project. And if we are lucky, end of this year, the CDE version will be available for us. But what does that mean for the productization? For some people of you, what I see here, so I saw already said we show already existing samples, prototypes on our fair here. And at the SPS in Nuremberg, we show really usable samples for companies who are interested in this connector. And in the upcoming year, not only Rutenberg, also Weidmüller, I'm quite sure Harkin goes the same way. We all in the productization. So we want to be really fast to have the connectors for everybody available. So that's a little bit the standardization. But now I will tell you a little bit about the productization. How does the product now looks like? So I told you before, we have the IP20 connector, we have the M8 connectors, we have the M12 connectors, and the M12 hybrid connector. So that's the current standard, which already exists. And that's the extension of the standard in the Edition 2. Let's start with the first one, the IP20 connector. And as you can see here, we have 3 different coding variants with a width of 9 mm for type 1, 11 for type 2, and that one, it's unfortunately not so good to see, is again 9 mm. But I come to that in the next slide. So the type 1 is designed for the standard 10-base T1L, 100-base T1L, 100-base T1, and 1000-base T1 for the American WireGuard 26 to American WireGuard 22. The main reason to do it this way is the auto negotiation between the PHYs. The type 2, I showed you on the slide before, is a little bit wider, 11 mm wide. And that's the interface is the same, just the housing. That's because we are focusing here on the multi-drop applications, the 10-base T1L and the 100-base T1, not multi-drop, sorry, the long range, the long distance, the 10-base T1L and the 100-base T1L. And if you think that for long distances, if you want to go to 1,000 meters, you need another American WireGuard. You need a thicker cable. And so we go down to American WireGuard 16. And that's actually quite a thick cable. And it makes no sense to make your PCB connector as small as possible as the cable is thicker. And the last one will be the type 3. The type 3, that's a standard for the multi-drop. So the 10-base T1S and 10-base T1M, again, for multi-drop application. To the M8, it looks almost the same. We have also 3 coding variants. The type 1 will be the Profinet standard. The other 2 will be an optional version for future applications. And what else can I say to that one? We have no internal shielding compared to the IP20 version. We have an external shielding via the thread, via the housing. And the next one I want to show you is the M12 connector. And you see here 6 different types of standards or of codings. But I would say it's 2 times 3 codings. let's start with type 1 to type 3. Type 1 to type 3 are connectors without internal shielding. That means they have a shielding. Of course, we need it with single pair Ethernet, but in that case, the shielding is again like a TM8 connector with the thread, with the housing. But actually, more and more customers plan with plastic housing. And in that case, you need a solution as well. And for that one, we have the internal shielding. So that you can use plastic housing. That's the main difference between these two types. So, yeah, I would say, Simon, tell us about the hybrid ones.
Thank you. Just go back one slide, because I look into your faces and you look confused. Why do we have connectors that we had before? That doesn't make sense, folks, does it? And the point here is that it's depending on the application. In the beginning, I said, well, the one to rule them all connector doesn't exist. Because when you have just one connector, which you feel it, what are you going to do with the unshielded guy? If you have one connector that works 10 base T1L and you plug it into a 10 base T1S system, it will not work. So the people are getting frustrated. Why I do plug this one in a 10 base T1S switch and a 10 base T1L switch, and there's no communication. So coding is necessary. But the big thing on this is that all of these systems have the same mating interface, and they have the same work principles like the connectors do. And we know coding now since decades in the connector industry. And the point where we decided with all of the other connector manufacturers, including the end users, we came up with this to make coding available so that it fits really everybody with the same connector style at the end of the day, but with reference to their application. And the reason why we've chosen the IEC 63171-7 was because there was already a lot of coding in. As you can see here, we have from the Hidwick connector, we have 7 different styles of code. Now, why are we doing this? There are applications which are for 24 volt. There are applications for 8 amp. There are applications for 16 amp. There are applications for up to 600 volt DC with 63 volts. And you can't put all of these requirements into one single connector. As I said, the one to rule them all doesn't exist. And that is the reason why we have realized several different coding options in our IP67 hybrid system. So we have, for example, 7 different types just for the hybrid. 2 to 4 power contacts, including functional earth or predictive earth, which is also a big difference whether we use functional earth or predictive earth. We have different power classes ranging from 600 volts to 63 volt. And of course, we have different product types here with the different power circuits using USB 1 or USB 2. The benefit is here that we support with these interfaces, an M12 interface, we support all of the different applications. And you know this already. It's very common in the industry. We got an A-coded M12. We got a B-coded M12. We got an X-coded M12. We got a decoded M12. So coding is very well depth. And they all fit on the same PCB layout. They all fit in the same housing style, but they only refer to different applications. And that's what makes this connector set basically so versatile. Another example on the versatility is that this mating interface is also used in the so-called IEC 61076-2-117. Now, for all of you guys who are using drives or engines or motors, all that stuff, which are using the M17 style, this is also incorporating an interface in a version that we have the same mating interface here in IP20, as well as the standard Ethernet. So this is a hybrid connector which has the possibility to use 3 different power classes or contact using SE or PE contacts. It goes around from M17 to M40, so from the smaller drives to the larger drives. And of course, it integrates all of the SPE variants that we see today, 10 base T1L or even 10 base T1S in the future, into just one interface that helps to realize SPE also on drives. So this just as an extra word, and Profinet said, okay, it's good to have the choice, but we define who are the interfaces that we're going to use for Profinet. And this is why, for example, here we always have the marker. This is for Profinet, this is for Profinet, this is for Profinet, or even this is for Profinet. Profinet made a clear statement on the what we would call general purpose SPE connected for IP20 and IP67. Taking into account that we now have this uniform interface, what can you do with this? And we've heard a lot of these use cases. And just to give you a few more of these use cases, specifically in the field of industrial applications, we see use cases in the factory automation style. We see use cases in the field of agriculture. We see data centers as well as battery storage systems. And we see, of course, building automation as possible use cases. And for factory automation, it's very obvious. We have sensors and actuators. We have machine control. We have robots. And of course, traditional filter systems, which can simply be replaced or extended by using single pair Ethernet technology. And here are just some examples of that. So a robotic application, and we just started a working group of humanoid robot. You've seen these humanoid robots that they do here in the US, Tesla, and also in China. It's amazing. The engines, the deterministic behavior of that requires small cables, that requires small interfaces, that requires small bending rate. And that's something that SPE can provide. So we have stays and weight saving. We have a much better flexibility and, of course, a partial protection. And with this hybrid connector, and there are several projects with interest also from the robotic manufacturer who are serving the automotive industry here in the US, like Ford, like Chrysler, like Daimler, and all the others. They want to have an actuator and a sensor being directly connected to the network, supplying to 16 amp power in order to make sure that the connector is just a simple connector that can do all of the work regarding the connectivity of an actuator. Oh, needs to be up. These are just some examples from the robotics industry, taking into account, for example, building automation. And there are huge discussions going on in the building automation, specifically for the energy consumption. That, for example, the window shades or even the lighting system or the HVAC, means the heating, ventilation, cooling, is controlled by a unified standardized network. And of course, security cams, access control systems, they all rely on a robust network. And that is currently investigated, for example, at the BACnet Consortia or with the KNX guys. Companies like Vago, like Belimo, like Dormakaba, and many others are exploring the possibility of using single pair Ethernet with this new interface in these types of applications. Another very interesting thing coming a little bit from the same market segment is the rack HP market. That means pumping, heating, refrigeration. These are the guys like the Danfoss, the Krivan, who are making refrigeration systems. So when you are in one of these supermarkets and you have these large cooling systems, they all work on Modbus RTU, right? And the companies like Aldi, or I don't know, in the US, the big companies, they want data. They want data how the products are being used inside these refrigeration systems. So these refrigerators become as a data supply for the users who are supplying the products into the refrigerator. They know when they take out the products, how many products they take out at what time. That facilitates the process of refilling these cooling systems. And Modbus RTU is not efficient enough to do this. So they're exploring the possibility of using single pair Ethernet for that topic as well. And we are working together with the ASACOM, which is the European Community of the Cooling and Heating and Refrigeration Industry, in order to explore the possibility of using single pair Ethernet as a successor of the Modbus RTU. So the working group has started, and we're exchanging the first interesting knowledge on that. Battery storage, very important, specifically for clean energy. If you've seen my previous presentation, decarbonization is a big topic. So if we have windmills who are running, they are storing their energy in battery. But these battery systems, they need to be managed. They need to be controlled. And this brings great possibilities for solar plants, for windmill plants, for smart grid implementation, for example, for the 10BASE-T1S technology. You see these racks here with battery storage system. Today they're using CAN, but They want to do more. They want to implement more devices. They want to implement more functionality in the battery management storage. So this is why reliable Ethernet data transmission can help a lot in order to get the data that we want out of these battery storage systems. And of course, it's also very helpful if you can scale up your system without having another, let's say, system being installed. So Ethernet is so versatile, you can add another line of data of battery storage system into the network. Last but not least, and I think this is the most mature technology using the single pair Ethernet technology. Some of them are already using with APL standard classical terminal blocks, but as more SPE is coming also into the process industry, which does not require the two wires for the intrinsically safe communication, SPE can also add a lot of benefit in these market segments. And so we see field switches coming out for APL, but also field switches for SPE that are being used in the process industry. All of that is using the 10 base T1L, the point-to-point standard, with ranges up to 1 kilometer. And as Thomas pointed out, if you have a direct connection of an AWG18 cable, which you require for the length of 1,000 meters, you need to have an interface that has a minimum 11-meter distance for 2 ports. And that's the application orientation that we see in this field. Speeding up and giving you one more example of the usage of multi-drop or even 10 base T1L is the agriculture industry. Means that, for example, and we know this in the region where we come from, we have Claas. Claas is just 50 kilometers or 30 kilometers away from where I live. A huge manufacturer of these huge machines. You got John Deere here in the US. But these machines are really just like your car. They're driving networks. And they have been using the so-called Isobus since ever, basically. And now there is a working consortium which is using single pair Ethernet to realize Isobus application also with single pair Ethernet. So in a nutshell, we were hoping to give you a little bit insight on what is the thought process, where we are with the new connector interface, and what you can do with this. Just briefly, we are representing the single pair Ethernet System Alliance. We are now nearly 97 members. So if you're interested in what we are doing, come over and join us. We have working groups exploring the potential of single pair Ethernet. As I just said, for example, humanoid robotics is one of the working groups, or together with the ASACOM, we're exploring the possibility of what is single pair Ethernet adding as benefit to the rack HP market. And of course, we have marketing events like here on the SPS in Atlanta. We're going to hope to see some of the faces here again in Nuremberg on the SPS. We have active working groups, as I said, and together, me, myself, and Tim colleague, we're working together. As I said, we're all partnering with a lot of us, and we come to an end, and thank you for your attention, because we believe that single pair Ethernet is really unstoppable. And with that new mating interface that we see now approaching the market, supported by all of the major connector manufacturers, we see really a breakthrough in the communication architecture that more and more device manufacturers are realizing their future generation products with the help of single pair Ethernet. Thanks again, and I would like to invite you for the next presentation, where my colleague Ken Crawford from White Miller would also like to give you a little bit more insight on what we do. What is the lead connector? It's the switch. Thank you very much. And if you have any questions, of course, feel free to ask. Thank you.
Any questions? Any questions?
So we made it all clear.
Was great presentation. Thank you. Quick question: have you given passes with people men's and student passes that we passed? Is the students and still?
So what's the question?
Sorry, I just messed that up. You're talking about this one
And 12.
that there are so many.
What? No, this one. Any things and items? In what again?
Sorry, I was not able to get that.
Those
Kann Anstieg von zusammengehen.
That, for example, does the type wheel have an instant machine what's in chilling?
No,
Oh, that's the theory.
Yeah.
No one.
It will fit here. Maybe this is a rendering, but size wise, it wouldn't make sense if you have a shielded connector and put it in an unshielded connector. So,
Give me SD post. If not,
thank you.
this is
thank you.
Thank you.
thank you.
Click to the news movie.